The cosmos has always been a silent narrator, telling its history through the faint whispers of light that travel across the infinite void to reach our small, blue world. For generations, we have looked up, capturing these photons, splitting them through prisms and gratings, and reading the resulting rainbows to understand what the universe is made of. We have built vast libraries of these chemical fingerprints, cataloging the spectral signatures of everything from common ice to rare earth metals, from the dust of comets to the hearts of dying stars. We thought we had a comprehensive index of the building blocks of the galaxy. But recently, a visitor arrived from the deep dark between the stars, a traveler known as Three-Eye Atlas, and it has brought with it a story written in a language we do not speak. This is the developing narrative of the third confirmed interstellar object to penetrate our solar system, a wandering fragment that has just rewritten the script on what we expect from the universe. NASA has released a fresh set of spectral readings derived from this object, and the results have sent a ripple of quiet confusion and intense excitement through the scientific community. To understand the magnitude of this moment, we must step back from the raw data and look at the human endeavor of discovery, the expectation, the surprise, and the profound realization that the universe still holds secrets we have yet to imagine. When the new data packet from Three-Eye Atlas first arrived, the atmosphere was one of routine curiosity. Astronomers and data analysts expected a confirmation of the familiar. Previous interstellar visitors and the myriad of comets and asteroids native to our own system have generally adhered to a standard chemical rulebook. We expect to see the signatures of carbon compounds, simple volatiles like water or methane ice, trace metals, and the telltale redness of grains altered by ons of cosmic radiation. These are the standard ingredients of the cosmic soup. The initial assumption was that Three-Eye Atlas would be another variation on this theme, a unique but ultimately recognizable piece of rock or ice. However, as the spectral lines were plotted and the graphs took shape, that assumption evaporated. Instead of the familiar peaks and valleys corresponding to known elements, the data revealed a series of absorption features that simply should not be there. In the world of spectroscopy, materials absorb light at specific wavelengths, creating dark lines in the spectrum that act as a barcode for that element. If you see a line at a specific nanometer mark, you know you are looking at hydrogen or iron or silicate. But the barcode returned by Three-Eye Atlas contained lines that did not match any product in humanity's vast inventory. NASA's spectral libraries are exhaustive. They contain thousands upon thousands of entries representing every material we have ever encountered or synthesized. They hold the signatures of terrestrial minerals found in the deepest mines, cometary ices harvested from the halo of the solar system, meteorite samples that have survived the fiery plunge to Earth, and even artificial alloys created in labs. Researchers ran the Three-Eye Atlas data against all of them. They compared it to interstellar dust analogs and complex organic chains. The search returned 0 matches. To clarify the strangeness of this discovery without drowning in jargon, we have to look at the specific anomaly. The data shows a narrow, sharply defined absorption line in a region of the light spectrum that is normally the playground of iron group elements, metals like iron, nickel, cobalt, chromium, and manganese. In a standard reading, you would expect the lines here to align with one of these familiar metals. But the depth of this feature, its alignment, and its fine internal structure were wrong. They were just slightly off, like hearing a familiar song played on an instrument that doesn't exist. It wasn't iron. It wasn't nickel. It wasn't any known alloy combination of the two. Faced with such an inexplicable result, the first instinct of any good scientist is skepticism. Was it a glitch? A smudge on the lens? A software error in the processing algorithm? To rule this out, the data was subjected to rigorous verification. NASA compared readings from two separate observatories, one situated on the ground, peering up through the atmosphere, and another floating in the vacuum of space. Both instruments, despite their different locations and technologies, recorded the exact same spectral line with nearly identical precision. This synchronization effectively ruled out instrument noise, calibration errors, or atmospheric interference. The reading was real. The ghost in the machine was actually a ghost in the rock. The mystery deepened as astronomers watched how this spectral feature behaved over time. 3i Atlas was not a static painting, it was a dynamic object moving through the intense environment of our solar system. As it approached perihelion, its closest point to the Sun, the object was subjected to intense solar heating. In almost all known materials, such heat causes spectral features to weaken or scatter as the molecules vibrate and bonds loosen. But the anomaly on 3i Atlas did the exact opposite. As the heat rose, the signal became stronger. The absorption line became more pronounced, more defined. This reaction suggests a material with a thermal response that defies our common experience. It implies a structure that perhaps locks into place or becomes more resonant under high energy, something formed under conditions of pressure and temperature that simply do not exist in our corner of the galaxy. Furthermore, as the solar wind hammered against the object, a phenomenon known as line splitting occurred. The single anomalous feature divided into two distinct components. In physics, this behavior is typically associated with magnetic interactions or asymmetrical electron structures within a complex compound. But again, when we look at our catalog of minerals and molecules, we find nothing that behaves this way under these specific conditions. The current scientific consensus, therefore, is one of cautious awe. The simplest interpretation is that 3i Atlas is carrying a compound or a mineral phase that was forged in an environment radically different from the early solar system that gave birth to our Earth. It is important to note that this does not violate the laws of physics. The material is real matter, obeying the fundamental laws of the universe, but it falls completely outside our physical experience. We are like villagers who have only ever seen wood and stone suddenly presented with a block of titanium alloy. We can hold it, we can weigh it, but we have no name for it and no history of how it was made. Theorists are already hard at work trying to reverse engineer the origins of such a substance. Some early modeling suggests that this material could have originated from the crushing, high-pressure interior of a super-Earth, a massive rocky planet with a mantle far denser than our own. Others speculate it could be the product of a carbon-rich protoplanetary disk where the chemistry of life took a different turn entirely. There is even the possibility that it is a radiation-shaped crystal network, a form of matter that grew slowly over millions of years in the hard vacuum of deep space, bombarded by cosmic rays until its very atomic structure was altered. Or, perhaps most excitingly, it represents a completely unknown branch of chemistry, a recipe cooked up in a distant stellar nursery that we have yet to observe. It is crucial to navigate these waters carefully. The lack of an explanation often invites wild speculation, particularly regarding artificial origins. However, nothing in the data suggests that 3i Atlas is a spaceship or a piece of alien technology. The unfamiliarity is chemical, not architectural. The spectral signature points to a natural formation, but one that nature produced in a factory we haven't visited yet. It is the first interstellar object to show a fully unique spectral signature since we began tracking these visitors. Oumuamua was strange for its shape and acceleration, but its surface looked somewhat reddish and familiar. 3i Atlas looks like nothing we know. In addition to the primary anomaly, the new spectra also revealed weaker secondary features in the near-infrared range. These faint whispers of data resemble the vibrational transitions of exotic carbides or polymerized grain networks' complex chains of molecules. but like the primary feature, their spacing and harmonics are just slightly off key. They don't fit the known patterns. This reinforces the conclusion that the object is not just carrying one strange rock, but is likely composed of a suite of matter that formed under a completely alien set of variables. As 3i Atlas continues its journey, swinging around the sun and heading back out into the dark, the focus of the scientific community is shifting. We have gathered the photons, now we must wait and analyze. As the object moves away and cools down, observatories will attempt to obtain cooler temperature spectra. These future readings are critical. They may help clarify whether this anomalous material is a thin crust on the surface, a component of the deep interior, or perhaps a transient layer of ionized material created by the interaction with the solar wind. Researchers are also keeping a desperate watch for fragments. If 3i Atlas were to shed dust or residual particles, and if we could somehow analyze those microscopic grains, we could move from remote sensing to laboratory confirmation. Even a single grain of this material would be a holy grail for material science, potentially unlocking new understandings of chemistry that could have applications right here on Earth. For now, however, we are limited to looking from afar, catching the light and trying to decipher the message. The story of 3i Atlas is a humbling reminder of our place in the cosmos. We often fall into the trap of thinking that the solar system is a representative sample of the universe. We assume that the geology of Earth, Mars, and the asteroids tells us the whole story of planetary formation. But 3i Atlas is a traveler from the great elsewhere, and it has brought us a piece of that unknown reality. It has shown us that our library is incomplete. To summarize the situation as it stands, NASA has confirmed the existence of a spectral feature that matches no known material. This signal has been independently verified, ruling out error. The feature behaves paradoxically under heat, strengthening rather than weakening, and exhibits lines splitting that hints at exotic magnetic or electronic properties. While there are natural explanations being proposed from super dense planetary cores to deep space crystallization, none have been confirmed. This object represents the first chemically unique signature ever recorded from an interstellar visitor. As of this moment, 3i Atlas remains the most scientifically unusual object we have ever observed crossing our skies. It carries with it the dust of a distant world, or the soot of a strange star, composed of matter that does not exist in our geological or meteoritic records. That fact alone is enough to redefine our understanding of the galaxy. The analysis is ongoing, and as the data is processed, more features may emerge from the noise. But one thing is certain: the universe is far more diverse and far more creative with its chemistry than we ever dared to dream. We are watching a developing scientific story that is far from over, a mystery written in light that we are only just beginning to read. The book of the universe has many pages, and we have just turned to a fresh one, covered in symbols we have yet to translate.